Okay, today we're going to review a little bit for our science test. So we're going to start with an example of how energy transfers from one object to another. And if you remember correctly, we had our Newton's cradle, and when it was in rest, it had potential energy. But the second that I take that first ball and pull it backwards, then let it go, it starts its transformation into kinetic energy and hitting those balls. Okay, so it's potential energy when it's at rest, and then once it starts moving, it has kinetic energy, the energy of motion. Then I go to the example of the vinegar and baking soda in our plastic bag example. And when we poured in that liquid, if you remember, that baking soda down at the bottom went through that phase change. It turned and started bubbling and fizzing, and that's how we knew a chemical change was taking place. And that blew up the bag, and it expanded that bag a little bit because of the change that was taking place. But if you also remember, it also had a temperature change as well. Okay, so it got colder. But note that things don't always just get colder as a phase change takes place. They can also get hotter as well. Then we go to our candle experiment, and if you remember, we started with heat energy in that candle, and that heat energy in that candle transferred down that wire for a couple of reasons. Number one, that wire was a good conductor. Okay, we talked about if it was made of something else, that it wouldn't travel as easily or at all, so it was a good conductor. And also, as that heat's transferring, it's causing those paper clips to fall down. And if you remember correctly, the first one to fall is the one that was closest to the flame, and then in line after that as it transferred. Okay, so that was an example of that heat energy transfer from one object to another, and also a great example of a good conductor. We can also talk about heat transfer in a different way if you think about it when it rains outside. Okay? Those raindrops create a big puddle on the ground. And then once it stops raining and the sun comes out, that heat energy is transferring to that puddle and making that puddle dry up. It's evaporating and going back into the clouds. So heat can be transferred lots of different ways. And this is just another example of how it can be transferred. In another example that we did, we had a couple of containers here. And inside of those containers, we had some cold water and hot water. And we talked about how heat transfers in these couple of experiments. And if you remember correctly, the example, I'm going to just call this number one. In example number one, when those molecules are really hot, remember they try to get away from what is making them so hot in that heat source. So if you remember correctly, that water ended up having a little tint of red. True that this water may have a little pool of blue here, but it didn't try to escape it because it knew that the molecules inside container number 2 were way too hot, so it didn't want to go there. So those molecules stayed in that container there. Whereas in this container, in container number 1, they were trying to escape that heat source because molecules, as they're heated up, they start to move faster, trying to get away from what it is that's causing all of that heat. And then we also talked about convection. And if you remember correctly, convection, we talked about many different examples of this. We talked about the pot on the stove and how as it's heating up, those bubbles, that gas is rising, those molecules, because we know warm air rises. And the cold air is starting to heat up, or the cold water is starting to heat up. So that was one example of convection. Another example of convection was our hot chocolate sitting on the counter to cool off, or our bowl of soup sitting on the counter to cool off. Okay, all of those things, that warm air rising. And then also that example of our hot air balloon and how, again, that warm air rising once we pull that string to fill that balloon and help that balloon rise, being replaced, and that cold air again coming down. Okay? So those were all great examples of convection. We talked about the difference between potential and kinetic energy, and we're going to start with potential energy first and how that was the stored energy. And if you remember correctly, we could change that potential energy in two ways: by the shape of the object and the location. And so the example that we did in class was changing the shape of that rubber band and stretching it out, and how all of a sudden we were a little bit more afraid of rubber band number 2 than we were of number 1. And then changing the location of an object can change how much potential energy you have. And if you remember correctly, we stood on the chair and then on the floor, and how if I change the location of something, it can change the amount of potential energy an object has. And then we talked about kinetic energy and how we can give that energy of motion to an object. So we did our roller coaster, and once we had the ball up at the top and we didn't let it go, it was actually potential energy. As soon as I let it go through that roller coaster ride, it then had kinetic energy. And then we also talked about potential energy when we dropped the ball from different heights. So if these were my books, if you remember correctly, we put that ramp, and then we measured 50 centimeters from that ramp and put a piece of tape. And at the top of that ramp, that ball had potential energy. As soon as I let it go, it transformed into kinetic energy. And if you remember correctly, the higher that ball was, the faster it rolled down to that 50 centimeter mark. And that's because I changed the position of that ball. And the same is true when I'm dropping the ball. If I'm dropping the ball at a height way up here, it's going to bounce a lot higher than if I were dropping it way down here. It's going to still get a bounce, just not as high. Okay? So again, that relates to the position of an object and its potential energy. And then finally, if you remember correctly, we talked about something having both potential and kinetic energy in class. And we had that dropping ball. And at the top, it had potential energy. When I let it go, it was transformed into kinetic energy until it hit that floor. Remember, once it's changing that direction, it's turning back into potential energy and then transforming again into kinetic as it's moving. Once it hits that height, as high as it can go, changes direction again. That stopping point there where it's changing from kinetic back into potential, and then continuing its journey until it stops. Okay, again, so things have both potential and kinetic energy in an experiment. And the same goes true with our roller coaster. If you remember a roller coaster, again, once we had that ball up there, before we started its journey, it had potential energy. We let it go, it transformed into kinetic until it hit the valley or the hill, turned into potential again before it started its journey again. Up at the top of that turn, it would have, again, potential energy before it began its turn in the loop, and again into kinetic as it's moving until the end of the roller coaster where it again had potential. Now we're going to talk about how things can go through that phase change. If you remember correctly, the molecules on a solid are really close together. On a liquid, they're a little bit more spread out. They take the shape of the container that they're in, and then in the gas, they're kind of all over the place in that state of matter. If I'm going through a phase change from a solid to a liquid to a gas, remember, I'm adding energy. Could be any form of energy, but I'm adding that energy in this example. If I were going in the opposite direction and taking it from a gas to a liquid and then to a solid, I would then be taking away energy. And as I do that, I'm not changing the mass of an object. So I'm not changing the mass of my water. Mass does not change. just the phase changes, okay? Just the state of matter that it's in will change. So the mass does not change. I still have the same amount of water here, even though it's a solid, as I do here when it's a gas and here when it's a liquid, okay? So the mass of a state of matter is going to stay the same as it goes through those phase changes.